In number 23, we're adding a new tortoise to the mix, and we'll update our table accordingly. We're adding a tortoise of weight 39. So we're going to add 39 here and a frequency of 1 to extend our table. And we want to know what happens to the mean, what happens to the median. Let's begin with the mean. We could go ahead and calculate the mean. We could do 13 times 12 plus 14 times 8 plus 15 times 5, add up all those values, get a total weight of the tortoises, and divide by 71, and that will give us the original mean. And then we can add in 39, divide by 72, and calculate the new mean. It's a lot of work when we can actually just look at these values and see whatever the mean's going to be, since the range of these values is from 13 to 20, the mean is somewhere in this range of 13 to 20. Like, there's no way the mean is going to be higher than 20 or lower than 20 or lower than 13. It's got to be somewhere in this range, which means when I add this number here, when I add 39 to the set, I'm adding a value that is definitely greater than the mean of the set, which just means if you think it like a balance, I'm going to tip the balance. I'm going to tip the mean, the average of this set, a little bit closer to 39, meaning it's going to increase. And so that means when I add this 39, the mean of the set will be larger than the mean of the original. And this gets rid of C and D. Median, we are actually going to have to find the median, because when we add this, we've got our 71 numbers, and then we're going to add 39 here. Whatever the median was, it's going to click over where now you're going to have two numbers that are to the middle numbers once you add that 39. And, if the average of them is the same, like if these two numbers are the same number that the original median was, then the median's not going to change. But if this number that's now part of the median is different, then we're going to average these two numbers to find the median, and it's going to be different from what it was. So long story short is we need to find the median here. We can't just eyeball it like we did the previous question. So to find the median, we have 71 tortoises. Let's go ahead and divide that by 2. When I do that, I get 35.5, which we round up. And this allows me to figure out that the 36th tortoise, either counted from the top or the bottom, from the least to the greatest or vice versa, will be my median for the original set. So let's count from the top of the table, from the smallest values first. My first 12 tortoises are 13s. The next 8 are 14s, and so cumulatively, that's 20 tortoises. The next 5 makes 25. The next 7 makes 32. And the next 9 makes 41. And so somewhere in here, we're going to find that 36th tortoise with a weight of 17. So the original median is 17. But now we go ahead and we add the 39. So what does that do? Well, now we've got 72 numbers, which we'll divide by 2. That gives us the 36th, and then we also take the one above it. The 36th and the 37th numbers then will be the median, or be the numbers that I'm going to use to compute the median. But notice the 36th and 37th are both in this row. Right? They're both in the 17 pound row. So yes, I've got these two numbers that I have to average, but when I average 17 and 17, I get 17. In other words, the median is still 17. So the median hasn't changed, and that's why the answer here is B.